Hey guys, I'm Francheska Javier and together with my groupmates Justine Dela, Cerna, Fernando Jimenez, and Go, we'll be talking about game theory. So what is game theory? Game theory is the study of strategic making where situations are called games and the participants are called players. It deals with problems in which a player's strategy depends on what other players do. Anytime we have a situation with two or more players that involves known payouts or quantifiable consequences, we can use game theory to determine the most likely outcome. But first, let us define terms commonly used in the study of game theory. First would be game, a set of circumstances that has a result depending on the actions of two or more decision makers. Players, a strategic decision maker with the context of the game. Payoff, set of circumstances that has a result dependent on the actions of two or more decision makers. Strategy, a complete plan of action a player will take given the set of circumstances that might arise within the game. So what are the different types of games? First would be simultaneous versus sequential, perfect versus imperfect, and normal form. Simultaneous versus sequential. For simultaneous, it means that each player has only one move and all of these moves are done simultaneously. Example would be rock, paper, scissors, game, 1, 2, 3 pass, and prisoner's dilemma. Sequential means, on the other hand, that no two players move at the same time, and players may have several actions or moves. Example would be board games and war games. Next type of game would be perfect versus imperfect. Perfect means that each player, when making a decision, is perfectly informed of all the actions that have been previously occurred. Example is chess, Monopoly, and tic-tac-toe. Next would be imperfect. It means that players are not informed of the previously occurred action. Example would be games of the general and poker. The last type of game is normal form. It is a game in which the strategies are listed along the margins of the table and the payoffs for the participants in the cells can be seen in the table. An example of these would be prisoner's dilemma. In this problem, it says here that Mr. JC and Mr. Eggs committed a crime and they have been arrested. The police thinks that they committed a more serious crime, but they don't have enough evidence to convict them. They need a confession, so they take them and put them into separate rooms so they can talk and play a little game. To try and force them confession, the police give them a choice. Case A, if only one of them confesses, one will be free and the other one will go to jail for 3 years. Case B, if both of them remain silent, then each will go to jail for a year. Both C, if both of them confesses, then each will go to jail for 2 years. This is the payoff table for the prisoner's dilemma. Each of the numbers that is in the table represents the number of years they're going to be spending in the prison, if ever. If we are going to sum up the strategy they have made, it can be concluded that both of them should remain silent, but from an individual standpoint, they notice that they could always gain by defeating if they have no control over what the other person is going to do. But if in totality, you'll take a look at the years of prison, if they defeat, which is 4 years, the option of being silent is still the optimal solution. Games in normal form are used to analyze one-shot games. Each player chooses one action and all of them chooses simultaneously. How do we decide? We can use the following: maximum solution and Nash equilibrium. Maximum solution involves choosing the strategy that gives you the maximum among your worst payoffs. This was proposed by the mathematician John von Neumann. For Nash equilibrium, there's a strategy for each player such that every player's action is the best response to the other player's action. Each player is using his best response in the game, so switching into another payoff would result into lower payoff. In other words, no players can reach a better payoff by changing strategies. Here is an example of a maximum solution. Two side-by-side restaurants have decided what specialty food to feature. Both have Bicolano cooks. Each of the two can feature Bicolano cooking, grilled food, or both. The payoff table is shown at the side. Here is the payoff table. The first step is to separate the payoff values of each player into two matrices. Step 2. In determining the maximum strategy of the row player, highlight the worst payoff in each row. Among the highlighted payoff values of the row player, determine the maximum. Versus step number 3, determine the maximum strategy of a common player. Do this by highlighting also the worst payoff in each column among the highlighted payoff values. In this problem, it appears that any strategy x the maximum strategy for each player is guaranteed a payoff of 6. Now, let's use the maximum solution for the prisoner's dilemma. We are using the problems we mentioned before. For the first step, let's separate the row into columns. So let's separate Mr. X with Mr. JC's strategies. The second step is to determine the minimum strategy of each player. For Mr. X, it is 0 and 2, and for Mr. JC, it is 1 and 0. After highlighting the worst payoff in each player among the highlighted payoff values of the row and column, determine now the maximum strategy. In this case, Mr. X's maximum strategy is 2 and Mr. JC's maximum strategy is 1. Therefore, this prisoner's dilemma has a maximum solution of 2 and 1. So, let us now consider the following payoff table for a 2-player game. Let us recall, as mentioned earlier slides, that a Nash equilibrium is a game in which strategy is chosen only if it is the best response. In this present method, we highlight the payoff table of the best response for each strategy. So in determining the Nash equilibrium, we should follow the following steps. Step 1 is determine the best response of the row player by highlighting it. In this payoff table, the row player has a response of 48, 43, and 33. Step 2 is to determine the best response of the column player to every strategy of the row player. To do this, highlight the highest payoff value among the second coordinates of the ordered pairs in each row. In this payoff table, player 2's best response is 48, 43, and 33. For the Nash equilibrium of this payoff table is 33 and 33. Now, that basically summarizes the terms and concepts needed in gaming theory. Thanks for watching!